All right, centripetal force and acceleration talks about things that go in a circle. So for something that goes in a circle, what keeps it going in a circle is a force that's aimed at the center of the circle, okay? So centripetal force, it's the force that holds an object in a circular path. Okay? And how it is directed towards the center of a circle. Okay. In the same way, centripetal acceleration, this is acceleration directed towards the center of a circular path. So if we were looking at something that's going in a circle, okay, the distance from the circle to the outer edge of the circle would be r, the radius of the circle, okay? And both centripetal force and acceleration are vectors, and they are both aimed at the center of the circle. So FC is what we use for centripetal force, and AC is what we use for centripetal acceleration. The units of force are, as always, newtons. The units of acceleration are meters per second squared. R, this is the radius of the circle, and that would be in meters. Okay, so imagine something going around and around in a circle. It would be going at some velocity, okay? Now you know that V is for velocity, and velocity is in meters per second. So if it's going around and around in a circle, what's keeping it in a circle is the force that's aimed at the center of the circle and the acceleration due to that force, because force is equal to mass times acceleration. The thing that's traveling, we'll call it m, where m is the mass of whatever is going around and around in the circle, and mass is in kilograms. All right, now, when we're thinking about linear motion, okay, so something that just goes like side to side. So when you're thinking of linear motion, your force, acceleration, velocity, mass, they are all in the same plane, which means they're all going the same direction, or they're going the opposite direction but like still in the same plane, okay, either like horizontally or vertically. They don't kind of mix and match. When you're talking about circular motion, the force and acceleration are perpendicular to the velocity and mass. Okay, so the mass is going around in the circle, so you can think of the mass as having a velocity that is perpendicular to the force and the acceleration. The mass doesn't really have a direction, okay, so I'm going to kind of put that in parentheses. It doesn't really have a direction, but because it is the part that's being moved, we're going to think of it as, okay, well, the only the only real arrow that matters that's coming off of that are the ones that are either directed to the center or the one that's directed perpendicular to those, okay? So mass, obviously it's not a vector, but it's going to be in the same plane as the velocity. All right, now what equations do we use? Okay, so you have an equation sheet. Your equation sheet has a few equations. Let's see. Trying to find the right one. Where are we? We haven't done energy. Here it is. Okay. So Fc equals mv squared over r. That's centripetal force. And centripetal acceleration is v squared over r. So those are the equations. They're on your formula sheet. So Fc equals mv squared over r. And centripetal acceleration is equal to v squared over r. And we've defined all the variables and their units up at the top for centripetal force and acceleration and all of these parts in the circle. Okay. Okay, so example question. Ricky spins her keys around on a 35 centimeter lanyard. The keys have a mass of 0.7 kilograms. I want to know the velocity that they travel to exert an inward force of 4 newtons. So that inward force of 4 newtons, that's my centripetal force, right? So my Fc is 4.0 newtons. I have the mass of the keys, that's 0.70 kilograms. The lanyard is the radius of the circle that's spinning. I need that to be in meters though. So the radius of the spin is 0.35 meters because there's 100 centimeters in a meter. And I'm looking for velocity for part A, and for part B I'm looking for centripetal acceleration. Alright, so for the first part I need an equation that doesn't have acceleration in it but does have velocity. So of my two equations, that's going to be the Fc one, okay? But I need to rearrange that and solve for velocity. So Fc equals mv squared over r. So I need to isolate velocity, get it all by itself. So I'm going to multiply both sides by r. So then r will cancel on the right. Then I'm going to divide both sides by m, so m will cancel on the right. Then I just have to get rid of the square. Well, to get rid of a square, you square root both sides. If I square root that side and I square root that side, I get rid of my square. So then v equals the square root of r times Fc over m, and I have r, Fc, and m. So now I can just plug them in. So the square root of 0.35, because now I have everything in my standard units, I'm not going to bother to write the units, times 4 over 0.70. Okay. So, square root 0.35 times 4 divided by 0.7, 1.41. And the unit for velocity is meters per second. So that's the answer to part A. And then part B wants me to calculate centripetal acceleration. So my formula for centripetal acceleration, now that I have velocity, is just that. So AC equals, why does that say 2? That should say just, it should be V squared over R. My bad. So V squared over R. So 1.41 squared over 0.35. Okay, and you get 5.68 meters per second squared. And that's your centripetal acceleration.